Hi, this is Kavita R, working as Assistant Professor, Faculty of Management, SRM Institute of Science and Technology, Chennai, Ramapuram. Today, we are going to talk about mastering measurement scales for research excellence. This is the very important and hot topic today. First, introduction to measurement scales. Measurement scales are very fundamental to quantitative research because they define how variables are categorized. This impacts data analysis and statistical test. So, correct selection is crucial for valid business insights. There are four levels of measurement. These four levels form a hierarchy. Each level determines appropriate statistical techniques. First, nominal scale. Second one, ordinal scale. Third one, interval scale. Fourth one, ratio scale. In this slide, we will discuss what is what in all four measurement scales. First one, nominal scale. Basic categorization of data is nominal scale. That is, categorical variables are used as nominal scale. Second one, ordinal scale, which adds meaningful order. That is, ranking our data is ordinal scale. Third one, interval scale. There will be equal interval between values. Ratio scale, true zero will be there. Meaningful ratios can be taken. Meaningful comparisons can be done. So, these four levels of measurement guide the accurate interpretation of our research findings. Now, we will discuss each in detail. First one, nominal scale. I have already told categorical data are used here. So here we are using this only for labeling purpose. Here we are labeling the data, which means assigning names to attributes. No inherent order is there. Example, for gender, we can assign male, female. For region, we can assign north, south, east, and west. For marital status, we can assign single, married, and divorced. So, likewise, assigning names to attributes is nominal scale. Statistical analysis, frequencies, percentages, mode are the common analysis. So, the nominal scale identifies categories without any order. It is the simplest form of measurement. Second one is ordinal scale. Ordinal scale categorizes data with a meaningful order. However, differences between ranks are not measurable. For example, customer satisfaction, we can order the data from poor to excellent. Education levels, we can order the data from elementary school to postgraduate degree. Likewise, Likert scale can be used. Likert scale means from strongly disagree to disagree, from strongly disagree to strongly agree, from like to dislike. So, likewise, Likert scale can be used. So, ordinal scale is ranking the data. Distances between ranks are not uniform. That is, unequal intervals will be there. Statistical use, medians can be used, ranks can be used, non-parametric test can be applied. Interval scale. The interval scale features ordered data with equal intervals. There is no true zero here. So ratios, if you take, are not meaningful on the scale. Example, for temperature, if you use 0 degree Celsius, there will be no absolute zero. Can be negative but no absolute zero. Equal differences represent here equal magnitudes. Mean, standard deviation, correlation, t-test, ANOVA are appropriate statistical test here. This we will again see in detail in the next slide. Now, ratio scale. Here there is true zero. Ratio scale includes ordered data with equal intervals, but it possesses a true zero. This means ratios are meaningful and comparable here. So, comparison of sales will get sales revenue. Proportion of the total market will give market share. If there is 0 employees, means no employees exist. So, there is true zero here, not in interval scale, right? So, all statistical operations are possible with ratio data. It offers the most comprehensive findings here or insights. Now, we will discuss once again the difference between interval and ratio scale for the clear explanation and for the clear understanding for you all. Interval scale, equal intervals. Differences between values are consistent and meaningful because, for example, the difference between 20 degrees Celsius and 30 degrees Celsius is the same as the difference between 30 degrees Celsius and 40 degrees Celsius. So, there are equal intervals. Second one, arbitrary zero. The 0 point is defined arbitrarily here, which means it doesn't represent the absence of the measured attribute. Example, 0 degrees Celsius does not mean there is no temperature. There is temperature. So, surely there is true zero. Next, we cannot calculate 0 because of the arbitrary 0 point. Ratios between values are not meaningful. 20 degrees Celsius is not twice as hot as 10 degrees Celsius. For example, temperature Celsius or Fahrenheit, calendar dates, standardized scores. These are the examples for the interval scale. Ratio scale. Here, similar to interval scales, the differences between values are consistent and meaningful. Here, there is true zero. The 0 point represents the absence of the measured attribute here. For example, a weight of 0 kilograms means there is no weight. Because of the true zero, ratios between values are meaningful. A height of 2 meters is twice as tall as height of 1 meter. So likewise, we can compare the ratios here. Examples for the ratio scales: height, weight, age, income, and reaction time. Now, choosing the right scale for the research is very, very important. Selecting the correct measurement scale is critical. It dictates the permissible statistical analysis. Always use higher scales than lower scales. Lower scales lose information. Higher scales provide richer data. Consider objectives. So you always align the scale with your research questions. Variable nature, which means understand the inherent properties of your data. Maximize information. Choose the highest possible scale for richer insights. This I have already told. So always choose higher scales. Next, last one, data validity. Ensure accuracy in your findings. So conclusion, correct scale selection ensures data validity and enables robust analysis. This leads to actionable, reliable business intelligence. It is an essential skill for evidence-based management. Thank you all for your patient listening. Thank you. Thank you once again.